Welcome to BSA Main Physics. This is a semester 4 question paper. Semester 4 paper classical physics. And here I read one question paper, and this is 2022 August question paper. 2022 August question paper. It is the latest question paper. You see the question paper and check the answers from our notes. Simply reading the question paper, no explanation. If you want the answer of any question, you can refer to our lectures, previous lectures. And here is the question paper. Fourth semester BSc degree examination, August 2022, post degree program under CBCSS Physics core course 3, PY 1441 Classical and Relativistic Mechanics. For 2019 admission of Kerala University. Maximum marks 80, time 3 words, section A. Answer all questions in a word or one or two sentences. Each question carries 1 mark. ഒരു മാർക്കിലെ ചോദ്യങ്ങളാണ്. പിന്നെ ഒരു വാക്കിലോ രണ്ട് വാക്കിലോ ഒരു സെൻറ്റൻസിലോ ഒക്കെ എഴുതാവുന്നതാണ്. ചോയ്സ് ഇല്ലാത്തൊരു പാർട്ടാണ് ഈ 10 മാർക്കിനുള്ള ഈ പാർട്ട്. Question number 1. Define initial frames of reference. Number 2. At what condition the linear momentum of a body will be a constant? Number 3. Differentiate between external and internal forces. What are inverse square forces? Write the form of expression for potential energy in inverse square force. Write the expression for kinetic energy and of an elastic collision between two particles. Define holonomic constraints. Number 8. Write the conditions at which a coordinate becomes cyclic. Number 9. Write the Galilean transformation equations. Number 10. Briefly explain twin paradox. 10 into 1, 10 marks. Section B. Answer any 8 questions. Each question carries 2 marks. Explain the concept of center of mass. Number 2, state and explain the law of conservation of angular momentum of a particle. Number 13, the value of the equal mass of a two-body system is always less than both of the individual masses y. Number 14, define impact parameter in scattering. Number 15, what are the differences between elastic and inelastic collisions? Number 16, define laboratory frames of references and center of mass frame of reference. Number 17, explain law of conservation of energy of a system of particles. Question number 18, what is a Tour's machine? Right is Lagrangian. Number 19, explain the significance of constraints in Lagrangian formulation. Number 20, define generalized coordinates with any one example. Number 21, in terms of generalized coordinates, explain whether the motion of a simple pendulum is one-dimensional or two-dimensional. Number 22, what are the differences between Lagrange's formulation and Hamiltonian formulation? Number 23, define Hamiltonian H and explain its physical significance. Next question, Number 24, write the Lorentz transformation equations and inverse Lorentz transformation equations. Number 25, explain the postulates of special theory of relativity. Number 26, briefly explain any four consequences of special theory of relativity. Section C, answer any 6 questions. Each question carries 4 marks. Number 27, calculate the deflection radius of an electron moving with a velocity of 1000 meters per second perpendicular to a magnetic field of 1 Tesla. E is 1.602 into 10 raised to minus 19 Coulomb. Number 28, explain the inverse square law of force and obtain the general form of potential in inverse square law forces. Number 20, calculate the reduced mass of CO molecule. CO molecule given that the atomic mass of C is 12 and of O is 16. Calculate the mass in atomic unit. Number 13, obtain the equation for motion of a compound pendulum using Lagrange's formulation. Lagrangian formulation. Number 31, what are the generalized coordinates? Explain its properties. Next question. Number 32. Deduce the principal virtual work. Number 33. Obtain Hamiltonian of a simple pendulum. Number 34. The kinetic energy and potential energy of a particle of mass m moving in a plane about a fixed point by an inverse square law of force minus k by r square r t is equal to half m into r dot square plus r square theta dot square and v is equal to minus k by r. Identify the cycle coordinate of the system. Prove that the angular momentum of the system is a constant. Number 35. Define Lagrangian and Hamiltonian of a harmonic oscillator in one dimension. Number 36. Calculate the length of a road 2 meters traveling in a speed of 0.8 c. Number 37. Calculate the change in mass of an electron moving with a velocity of 2.4 into 10 raised to 5 or 10 raised to 8 meter per second in space. Assume the standard mass of electron. Number 38. A spacecraft is moving related to Earth. An observer in the space found that, according to his clock, 3603 seconds elapsed between 8 a.m. and 9 a.m. on the clock in the spacecraft. What is the speed of spacecraft related to the speed of Earth in terms of c? Next question, section D. So section C, 6 into 4, 24 marks. Section D, answer any 2 questions. Each question carries 15 marks. Essay type questions. Number 39. Derive the laws of conservation of energy, momentum, and momentum for a system of particles. Number 40. Calculate, obtain Kepler's laws of planetary motion. Number 41. What are the significance of degrees of freedom in Lagrangian mechanics? Write and explain the Lagrange's equations motion and solve the problem of simple pendulum using Lagrange's equations. Number 42, derive Hamilton's equation of motion. Prove that a cyclic coordinate represents a law of conservation of Hamiltonian formulation. Next question. Explain the Michelson-Morley experiment and discuss the results of the experiment. A. Experimental setup and objectives of the experiment. B. Experiment. C. Results and interpretation. Number 44. Derive the velocity addition equation special theory of relativity. Explain the significance of velocity addition equations. Here it is 2 into 15, 30 marks. That is a question. And these questions you can answer very, very well if you attend uh, the classes, my classes on classical physics. That is all. Thank you very much.